right, here we have our geometry and 1 through 65 review. There are 30 questions here. Several of them come directly off the test. So you're going to pay close attention, do as many of these as you can, watch and see what kind of work that we're going to need to do and show on each of these to get credit on the test. We see question number 1 showing up from lesson 37. We've seen stuff like this before. Which line is parallel to y equals 6x plus 3? When we talk about parallel or perpendicular, we automatically want to take our attention to the slope. And then we want to start looking through our list of options. And obviously, when we have two lines in slope-intercept form, we want them to be parallel, then that means that we want our slopes to be the same, which is automatically going to eliminate a couple of these for us. Notice that here, the slope is negative 1/6. Although that is perpendicular, it is not parallel. Down here, the slope is 1, which is not parallel because it's not the same. So it leaves me with A and B as an option. I do need to show work here. So on A, I need to switch this over. It is not in slope-intercept form. So from 2y minus 12x equals 0, I need to add 12x to the other side. So I'm going to get 2y equals 12x plus 0. Don't really need to do that. Divide by 2. So I get y equals 6x plus 0. That's enough. I mean, if we can do D, what we'd end up with is y equals 6 divided by negative 4. So 6 over negative 4x, which is y equals negative 3 halves x. So that's not going to be right. But because this is 6x, our answer is going to be A. Okay, because the slope comes out the same. Okay. Question number 2. I'm going to drag this over. The side of a wooden chest is a quadrilateral. It means it has 4 sides, with AB being parallel to CD and BC being parallel to DA. Okay, so we have a parallelogram. If measure angle A equals 90 degrees, what is the most accurate description of this? Well, the most accurate description of this is that it is a rectangle. We don't know anything about the side lengths. Okay, so we can't make any observations about it being a square. Okay, so if we look down through here, both pairs of opposite sides are parallel, so it's a parallelogram. Since one angle measures 90 degrees, it's a right angle, and a parallelogram with one right angle is a rectangle. That's our answer. Okay, it's not necessarily a square like we see in B, because we don't know if it's a rhombus. Both pairs of opposite sides being parallel, and C doesn't make it a rhombus, so that's false. It's on D, it says one angle measure 90 degrees does not provide enough information. Well, that's not true. We can determine that it's a rectangle. Okay, so we get A out of that. Now let's come down here. Okay, find the area of the rhombus. Area formula of a rhombus, question number 3, can be found in lesson 22, finding areas of quadrilaterals. And what we find in there is that diagonal 1 times diagonal 2 divided by 2 is going to give me my area of a rhombus. Because diagonal 1 is 4x plus 6, and diagonal 2 is 8x plus 12, we want to multiply those and then divide by 2. Okay, so all of this divided by 2. Okay, so 4 times 8, 4 times 8 is, what do we get there? We should get 32x squared. Let's see, then we get 4x times 12, which is 48x. 6 times 8, that's 48x. And 6 times 12 is 72. We'll take all that and divide by 2, which is going to leave me with 16x squared. 48 and 48, I believe, comes out as 96, but 96 divided by 2 comes back to 48x, and 72 divided by 2 is 36. So this is our answer in centimeters squared. 16x squared plus 48x plus 36 centimeters squared is our answer, and that's our work. Biggest mistake that's made here is not dividing by 2. Plenty of people will FOIL, but they won't divide by 2, and so therefore they'll get the answer wrong. But make sure that you're showing your work so that you can get full credit. All right, 4, the vertices of a square. The fact that they're saying it's a square is important. It showed me that ABCD shows up at the midpoints of the sides of the larger square. We want to find the perimeter and area of the square that's on the inside to the nearest hundredth. All right, because these are midpoints, that means that these lengths here represent this. So what I could do from here is do 2.5 squared plus 2.5 squared and find AD. And that would probably be the simplest way for most of you to do that. Okay, 2.5 squared plus 2.5 squared, okay, is going to equal the rest. So 2.5 squared plus 2.5 squared comes out to 12.5, and then we want to square root that. So square root of 12.5 comes out to 3.5. Ultimately, though, what we're going to get here is a 45 right triangle where we'd have 1 to 1 to 1 radical 2. So we could take that as 2.5 radical 2 as one side, and then multiply that by 4. But it does want it rounded to the nearest hundredth. What leaving it as 2.5 radical 2 does is that it allows me to get a more exact answer. So as I take my calculator and I clear some things out, I got 2.5 square root of 2 times 4 will give me my perimeter. Okay, so 14.14. So P equals 14.14. Because that square on the inside is a square, in order to find an area, we can simply take 2.5 times square root of 2, close all that up, and then square it, multiply it by itself, and get 12.5 for my area. Okay, we've got centimeters and centimeters squared. Okay, so what we should get for that, double check, perimeter 14.14, area is 12.5 centimeters squared. Again, we have to have the work. Okay, so if you plug something in your calculator, tell me what you plugged in there. Okay. Jenny's birthday cake is circular, has 12 centimeter radius. Her slice creates an arc with a central angle of 30 degrees. What's the area of her cake? So this is area of a sector formula, and our formula for that is pi r squared, which is the formula for area of a circle, times the measure of my arc over 360. So we're going to take pi times our radius. Okay, has a 12 centimeter radius, 12 squared, and we're doing a 30-degree angle. We want our answer in terms of pi. So all we really have to do is leave pi out of it, which is fine. So we're going to clear that out from our last one. We've got 12 squared times 30 divided by 360. It's giving me 12. So I'm left with 12 pi, let's see, centimeters squared as my answer. 12 pi centimeters squared is my answer there. That comes out of lesson 35, finding arc lengths and areas of sectors. Now I'm going to, let's see, we can do 6. Find the bases and faces of the polyhedron, then classify the polyhedron. My base is this shape down here along the bottom. It is 1, 2, 3, 4, 5, 6, 7, 8. Hold on, let me try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9, so the base is a nonagon. Okay. Faces. Faces are these guys here, and so there are 9 triangular faces. And this isn't going back to some just very far distant nonagon. It's actually all going back to a singular point. So the name of this, because it's all going back to a singular point, is a non-agonal pyramid, because it all goes back to a single point. Okay, and that's what I've got there. Okay, that's 6. Let's scroll on up here to get our 7. We've seen this guy before. Find the measure of each numbered angle. Notice that we have 2 parallel sides cut by transversal here, which means what we've got is same side interior angles between 117 and angle 3, and we have a linear pair between 117 and angle 2, which means that angle 2 and angle 3 are going to be the same. Also, they are alternate interior angles. Okay, because we have 2 parallel lines cut by a transversal, then alternate interior angles of that transversal are congruent. So all I have to do is do 180 minus 117, which I believe is 63 degrees. Yep, 63. 63 degrees is angle 3 and angle 2. Okay, and because this is an isosceles triangle, my 2 base angles are the same. Okay, so those 2 base angles are the same. That's how I'm going to find angle 1. We're going to take 63 times 2, or 63 plus 63, and 60 and 60, let's see, would be 120. So I should get 126. So I'm going to subtract 126 from 180. I'm going to get 54 degrees for angle 1. So 63, 63, and 54 are my angles there. Okay. 8, Vanessa wants to measure the width of a reservoir. She doesn't want to get her tape measure out. She measures a triangle on one side of the reservoir, shown on the diagram below. What's the width of the reservoir? What you want to see is that X is the midpoint of AB because it goes 120, 120. Y is the midpoint of AC. And because that is true, that means that this XY is a mid-segment. And the mid-segment is always half, okay, half of the third side. So if 150 equals 1/2 x, okay, then I'm going to, rather than divide by 1/2, I'm going to multiply by 2. So 300 equals x, 300 meters that is. So 300 meters is my answer there. Okay, 9 is our yield sign question. I've seen people continue to miss this. So we're going to put our yield sign, except we're going to put our yield sign upside down. We know that this is 36. And whenever I cut it in half, when I bring this line down through and make it a perpendicular bisector, it means that's going to make that 18. Because it's an equilateral triangle, all the irregular angles are 60 degrees, but that's going to force that to be a 30. So there's 2 ways of doing this. You can look at it as a 30, 60, 90 triangle, or you could look at it as a simple right triangle. It's faster to look at it as a 30, 60, 90 because that means 18, 36, which means this is 18 radical 3, and 18 radical 3 is 31.2 in your calculator. And because it's 31.2, it means it's less than the 36 by 32. Okay, there's my 36. I'm only 31.2 of my height, which means I've got enough metal to make it. So 31.2 is the number we're looking for there. Either do 18 squared plus b squared equals 36 squared and then solve for that length and then get it in as a decimal, or show me a picture here where you're showing me how you got 18 radical 3 and you just plugged that in your calculator, you got 31.2, and so yes, it is enough. It's 31.2 inches tall. Okay, you can go back. I want to say that this comes out of lesson 56, which there's certainly a video on of me doing that exact same question, probably a little slower and in more detail. Question number 10 comes from lesson 58. Again, another good lesson to go back and look at. This one comes down to, again, being able to draw the picture and draw it correctly. So I'm not going to show you how to draw it wrong. I did that in that video. I'm going to try to show you how to draw this correctly so you don't make a mistake. We have the sun's rays coming across, and it's important to note that the sun's rays are our tangent line, and our tangent line is at a right angle with our radius. Okay, so as we look at this, my astronaut's up here, and most times people put the hypotenuse on the wrong side. They make the hypotenuse the tangent line, and it's not. The hypotenuse is the line that runs from the center of the Earth to our astronaut. And our radius of our Earth is 4,000, and he's 50 miles above the Earth. I know we're not to scale. And our radius is still 4,000 to our tangent line, or to where the sun's light meets the crust of the Earth. And so if we want to find this, what we're going to do is use the Pythagorean theorem again, except we're going to do 4,000 squared plus x squared equals 4,050 squared. So obviously we're dealing with some pretty big numbers. I want to say like 16 million on 4,000 squared, if I'm correct. We get 1, 6. And then let's see, 1, 2, 3. We get 6, 0, 1, 2, 3, 4, 5, 6. So 16 million plus x squared equals, we got 4,050 squared, which is essentially the same thing except bigger, 16,402, or 16,402,500. Okay, all we need to do is subtract the 16 million, which is going to leave me with that 402,500 that's left over. Then we're going to square root that. So if we want to find out how far that astronaut is from where that sun comes up, we're taking our square root. Let me pull it up so you can see it. Okay, clear that out. Square root of 402,500. Okay, and we should get 634 miles, I think is exactly what they're looking for, 634 miles. Okay, check my answer key just to make sure I'm on the right track there. 634 miles is their answer. Okay, that's question number 10. Need to be able to draw the picture, need to be able to put the math together. That's what I expect to see on that question. Okay, that's question number 10. We're about 1/3 of the way there. Okay, to determine the amount of wrapping paper needed for a rectangular box, Ryan finds the surface area of the box. There's no overlap or anything like that here. How much wrapping paper is needed if the box measures 9 by 6 by 8? First thing I do, they tell me about something like this, is I go and I draw it. Okay, 9 by 6 by 8. So let's do 9 by 6 by 8, keeping in mind I've got a 9 over here and a 6 over here. All right, we're looking for surface area, so I need a formula for this. Surface area is the area of all sides of this. So that's going to include the lateral area plus the two bases. And lateral area is perimeter times height. And to finish out surface area, I need 2 times the area of the base polygon. Okay? So surface area here, perimeter, is 9 plus 9 plus 6 plus 6. So 18 plus 12 is 30. Okay? 30 times my height on my box is 8, plus 2 times the area of my base polygon. Well, that's 9 times 6, which is 54. Okay, so I can do it just like that. Now, you could try to find the area of all 6 sides and add them together, and you're going to get the same thing. But I do expect by at some point that you're going to start using the formulas that you've got because they're quicker. But if you don't, make sense out of it and put it together. Okay, we should get, I believe, on our surface area, hopefully I've got this right, 348 inches squared. 348 inches squared is what I get at the end of that. Boom, I drew my picture, did my math, remembered my formulas, okay, substituted in my numbers, plugged in my calculator, and I came out with the right answer. 12, compare the volumes of the cylinders. Volume, as in most figures, is area of the base polygon times height. But when we're talking about cylinders, that area of the base polygon means pi r squared times height. So I've got to do that with each of these. Now, that right there will throw you off. Okay, that will get you the wrong answer because people will look right past that and get the wrong thing. So let's take this first one. Okay, move this guy over. Okay, if we have to, we'll move some things out of the way. Okay, so let's see. We got second pi. My radius is 3.5 squared times my height of 7. Okay, 269. Okay, 269.4 centimeters cubed. And as I look at their answer on 12, all right, they're in the end they're just going to want you to look and see which one has the biggest area, or sorry, volume. Okay, let's clear that out and try this other one. We've got pi times 4.5. I need 9 divided by 2, so 4.5 squared times 4. Okay, that's 254.5. 254.5 centimeters cubed. Which one has the greatest volume? Well, cylinder L. Cylinder L has the greater volume. And that's the correct answer. Okay, that's 12. Okay, so as I'm doing this, I'm taking what I've put in my calculator and I'm showing that in formula form more than what I'm just showing you here. I'm showing you how to use your calculator, but you need to show me that work in your box sheet. Okay, 13, find equal vectors. First off, start with what my vectors are. Okay, A, B equals vector. Okay, show me. All right, I'm going to the right 2. Okay, always do my x value first. I'm going up 3, then my y value. F, G equals vector. Let's see, I'm going to the right 3. I'm going up 3. Okay, C, D. Okay, I'm going to the right 2. I'm going up 3. Okay, IH. And IH because I is where I'm starting from. I is going left 2, down 3. That's why I get vector -2, -3, and then JK. Okay, I'm going to the right 4. I'm going up, I want to say 1, 2, 3, 4. I'm going up 6. All right, so they're going to ask you, what are the equal vectors? Well, equal vectors are ones that are equal, that have the same, that are the same. And then what are the opposite vectors? Well, vectors that have opposites. Okay, 2 goes to -2, 3 goes to -3. Those are opposites. And if two things are the same, then they're opposite to the same thing. So A, B, and CD are equal. A, B, and IH. CD and IH are opposite vectors. Okay, but the work I want to see there is I want you to tell me what is the vector notation for each and every one of those. Then you can prove to me what is opposite and what is equal. Question number 14 comes from lesson 64, angles interiors to angles. If I'm looking for the measure of BPD, that means I'm looking for this guy right here. I find that by taking these intercepted arcs, because these two angles are going to be the same because they're vertical angles. Vertical angles are congruent. So I take 152 plus 142, and I divide by 2. Okay, I find the average in order to find those interior. Okay, so 152 plus 142 is 294. Divided by 2 is 147 degrees. Okay, 147 degrees on 14. Measure angle BPD equals 147 degrees. Okay, let's see, 16. 16, a lot of people miss this question because they make it harder than what it really is. As I'm looking at this question, I know I want to find the area of a triangle. In order to find the area of a triangle, I need base, I need height, and I need to divide it by 2. But oftentimes we try to make it more difficult than it is. I'm going to show you the easy way to look at this. If we look at this as my base, then the height is the perpendicular line from this line to the opposite vector, or sorry, the opposite angle or vertex. Okay, so I can just simply count this 1, 2, 3, 4, 5 as my base times height 1, 2, 3, 4 divided by 2. 20 divided by 2 is 10 units squared. Okay, 4 times 5 divided by 2. Okay, and we're all done. At least with that question anyway. 17, at least we're over halfway. graph and find the area of the figure with the vertices. All right. Let's see. All right, we want these vertices, -3, -3. All right, graph and find the area. So let's move over to some place where we can do some graphing. Our virtual graph here. Okay. Let's make a coordinate plane. Okay, I'm going to look at my sheet here so I can see we got -3, -3. 1, 2, 3, 1, 2, 3. Okay, so that's my first spot. Let's see, we got -2, -1. Okay, looks like we're not too far away there. 2, 1, 2, 1. And 2, -3. 2, 1, 2, 3. I'll make sure I got this right. 1, 2, 3, down 1, 2, 3. -2. Okay, hold on, I see where I made my mistake. It didn't look right. -2, 1. All right, so what I have here is a trapezoid, okay? It's not too hard to find. We're just doing base 1. So across here, the top, 1, 2, 3, 4, because everything comes to a nice spot, times base 2, plus base 2. So 1, 2, 3, 4, 5, plus 5 times my height, 1, 2, 3, 4, divided by 2. Well, 4 plus 5 is 9. 9 times 4 is 36. 36 divided by 2. So if I look at my answer here, let's see. Where are you at here? 17? Let's see. We get 18 units squared. So that's my area right there. Okay, so if you need graphing paper, by all means, you'll have access to it. Let me get back to this guy. 18. Let's see, we've got a community park building. It's square, that's important, with sides that measure 130 meters. So let's draw a square. 130 meters, 130 meters. They're all 430 meters. To separate this picnic area from the play area, it's split by a diagonal line. And we want to know what is the length of that diagonal line. Well, we have because squares have right angles, what I have here is a right triangle. So you have two options here, and I think several of you know this. 130 squared plus 130 squared equals c squared, and go ahead and solve from there. Or I could look at this as a 45, 45, 90 right triangle, where it's going to be 1 to 1 to 1 radical 2, or 130 times radical 2. In either way, I'm going to get the same answer to the nearest tenth. Okay, 130 square root of 2. Okay, I get 183.5. Let's see if that's right. 183.8. But that's actually, no, 183.8 is the correct answer. Just to show you that the other method works, if we take the square root of 130 squared plus 130 squared, boom, I get the exact same answer. So 183.8 is my answer. Okay, and I believe it's in meters, 183.8 meters. Okay, 19. 19, find the area of the sector. We've done this. You've seen this formula, but you're going to see it again. Pi r squared measure over 360. Okay, pi. Let's see, we want it in terms of pi. That's always good news. Our radius is 4. Our measure of our angle is 54. So we don't have to use pi. So whenever I come into my calculator, all I do, 4 squared 54 divided by 360. Okay, 2.4 centimeters squared. Okay. All right. Number 20, 2/3 of the way done, hope to be done soon. Find a line that's parallel. Okay, we've talked about this in the beginning. So we want something that uses 2x, goes through this point. So y minus y1 equals m times x minus x1 would be the formula I would use. So y minus, make sure we're using this. So y minus 4 equals my slope, which is 2x minus 6. Okay, simplify, y minus 4 equals 2x minus 12, because we're distributing the 2. Add 4 to both sides. Y equals 2x. Be careful here, negative 12 plus 4 should be negative 8. Y equals 2x minus 8. That is correct answer. That's out of lesson 37. Okay, number 21, solve the proportion. Cross multiply and divide. That's all we really need to do here because it's proportional. So we're going to get 99W equals 21 times 13, which you can do that. 21 times 13, 273. Okay, divided by 99. W equals 273 divided by 99. Comes out to 91 over 33. Okay, again, we'll check that. 91 over 33 is our answer. Okay, 22. All right, so we're told that these two triangles are similar and we need to find x, y. Okay, so again, we set up a proportion here. Our big triangle over our little triangle would be 13 to 6.5. 13 to 6.5. Okay, so then we want to set that up as big triangle over little triangle is 15 over x. So cross multiply and divide. So 6.5 times 15 is 97.5 divided by 13 comes out as 7.5. X equals 7.5. Okay, because they're similar. All right, that's 22. S equals 7.5. They don't use an S there, so it's a little confusing. I will take X equals 7.5. Show your work. 23. I'm going to make you listen here. I'm going to save myself a little bit of writing. It says identify the bases and the faces of the polyhedron, then classify it. My bases, okay? 1, 2, 3, 4, 5, 6, 7. 7. So what I have there, what seven-sided figure? If I remember this right, it's a heptagon. Okay, so we have 2 heptagons for the bases. 2 heptagons. Okay, faces are 7 rectangles. Okay, classify the polyhedron, which is my name. We would say that this is a heptagonal prism. It's different than the pyramid we looked at because it has 2 parallel bases. Heptagonal prism. Okay, so usually on those, your answer is your answer. Okay, slide over here, solve for S in the isosceles triangle. In an isosceles triangle, my base angles are my angles that are opposite my equal sides, which means they're the same. So what we're going to do here to solve for this is take 180 minus 47, because we know that there's 180 degrees in here. 180 minus 47 comes out to 133. And my base angles are congruent, so they're going to take that 133 and split it evenly, which is going to come out to 66.5 degrees shared evenly between them. S equals 66.5 degrees. That's lesson 51, properties of isosceles and equilateral triangles. 25. We want to show that this is a mid-segment. Okay, you've seen this question before, so I probably won't spend as much time on it. One of the things you want to know that they're going to state is we need to state that L is at 0, 0. In order for this to be a mid-segment, it needs to be parallel to the third side, the side that it doesn't share or doesn't touch, and it has to be half the length. Okay, so we can do a lot of this using right triangles, that type of deal. So let's look at the slope here. It's going to go up 1 over 4. So KL has a slope of 1/4. We need to see that AB has a slope of 1/4. Notice that it goes up 1 and over 4, up 1 over 4. So AB has a slope of 1/4. Okay, then we need to find the distances. We need to see that it's half the distance. Well, that's 1/4. So we could do 1 squared plus 4 squared equals c squared. 1 squared is 1. 4 squared is 16, so I'm going to get square root of 17. Okay, as we've already seen here, this is 1, 4, 1, 4. You could look at that as 2 squared plus 2 squared plus 8 squared if you wanted to. But in any case, if this is radical 17 and this is radical 17, then what that is 2 radical 17, which means KL is 1/2 of AB, okay, because radical 17 is 1/2 of radical 17. Okay, you're looking for a lot of that information there. Again, you've seen that question before, so I don't want to spend a lot of time there. Okay, find the perimeter. Okay, this is based upon 30, 60, 90 triangles, lesson 56. If this is 60 that we see and 90, then this is 30, then we have to deal with our ratios. Okay, so 4.4 is my short side. My hypotenuse is 2x, so 4.4 equals x, and AC equals 2 times that. Then, if I don't want to get this wrong, 4.4 times 2, okay, is 8.8, okay, and this is 4.4 radical 3, okay, because this is x, 2x, x times radical 3. Those are my ratios on my 30, 60, 90. So what I'm doing is I'm taking 4.4 plus 8.8 plus 4.4 radical 3 to get my perimeter. So I'm going to show adding those things together, not just on my calculator, but on my paper, plus 8.8 plus 4.4 square root of 3. Okay, and I'm going to get 20.8 rounded to the nearest tenth of a centimeter, so 20.8 should be my answer there, and it is 20.8 centimeters. Okay. All right. Obviously, I'm trying to move through this quicker. You're going to have more time to do your test than I've had to do 30 questions. Find the area in the perimeter of the polygon with vertices at those places. Okay. All right, we'll switch over to go back to our grid paper. Let's see, hopefully okay, question 27. Okay, we've got -3, 0. So right there. We've got 3, 4. Right there. We've got 5, 1. 1, 2, 3, 4, 5, 1. And we've got -1, -3. So eyeballing it looks like a rectangle. We want to find the area and the perimeter. So the first thing I want to do, we need to find our lengths of this. Okay, we can do that in a multitude of ways. You could use your distance formula. I'm probably not. I'm probably going to use my Pythagorean theorem. I'm going to go up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so 4 squared plus 6 squared. Okay, I've got 16 plus 36. Let's see, which I believe gives me 52. So I've got square root of 52 right here. Okay. This, if I look at it, I'm what, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, which tells me I got square root of 52 there. Okay. I'm at 1, 2, 3, 1, 2, so 3 and 2. So I got 3 squared plus 2 squared equals c squared. I got 9 plus 4. So I got square root of 13. Okay. And the type of answer they're looking for here is specific. Okay. So area would be length times width. So it would be radical 13 times radical 52. But let's see if we can take 52 down. Okay, that's going to be 2 and 26, I believe. 2 and 26, 2 and 13. So that's 2 radical 13, really. So all I really need to do is take radical 13 times 2 radical 13. Those 13s will multiply by each other to be 13. And I'll wind up with 2 times 13, which is 26. My area is 26 units squared. Okay, perimeter is radical 13 plus 2 radical 13 plus radical 13 plus 2 radical 13. Well, 2 radical 13 plus 2 radical 13 plus radical 13 plus radical 13. Keep in mind, there's 1s in front of all these. So 1 plus 2 is 3, plus 1 is 4, plus 2 is 6. So I get 6 radical 13 units in terms of my length. So 6 radical 13 units. And come back here. 28, lateral area and surface area. Okay, lateral area, okay, is, give me a second here. Lateral area is perimeter times height. Okay, and perimeter of a cylinder, okay, is going to be 2 pi r, there's my h. Okay, surface area is 2 pi r h plus 2 pi r squared, because we want to add the 2 bases to it. Okay, now because they're showing that line all the way across, I want to make sure I'm using radius, so my radius here is 2. Okay, we're answering our stuff in terms of pi, so lateral area is 2 times pi times 2 times 9. So that's what I've got is 18 times 2, so I got 36 pi meters for my lateral area. Now surface area, I already know that I've got 36 pi, so I don't have to do all that work again. So I got 36 pi, and I've got 2 times pi times 2 squared. So this is going to come down. I've got 4 times 2, which is 8. So I've got 36 pi plus 8 pi. So my surface area should come out to 42 pi meters squared. And this is meters squared because both of them are area. Let's check our answer on this. Lateral area 36 pi meters squared. Surface area 44. I thought maybe I messed that up. Can't add in my head sometimes. 44 pi meters squared. 36 plus 8 is 44. Okay, that's 28. Let's come down to 29. Surface area of the cylinder. Here we want to use 3.14. Surface area is just the same formula we used up there. But let's do it again so we remember. Surface area equals, let's see, we got 2 pi r h plus 2 pi r squared. Okay, 2 pi r h plus 2 pi r squared, where my radius is 11. So 2 pi 11 times 11.5 plus 2 pi 11 squared. So that's what I want to plug into my calculator, and that's what we're going to do over here. All right, 2 And we're using 3.14. That's important. 3.14. Let's see. 11. And times our height, 11.5, plus 2 times 3.14 times 11 squared. If we've done all that right, we'll check our answer here. We should get 1,554.3. And that's going to be in centimeters squared. Last question. Find the volume of the cylinder. Volume of the cylinder is pi r squared times height. Okay, we're using 3.14, so volume equals 3.14 times my radius of 6 times my height of 12. 3.14 times 6 times 12. Pull that calculator back out. Okay, show our work. 3.14 times 6 squared. I'm sorry, I didn't put that square in there, did I? Squared times 12. 1,356.5. 0.5. Because it's volume, we want feet cubed. Folks, that is it for me. Like, subscribe, hit the notification bell, get our updates, and all the fun stuff. Hopefully this review has been a help to you as you get ready for your test. Make sure to study. Make sure to write down formulas. Practice, 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 and you'll be fine.